So the VMware vDefend firewall portfolio has a bunch of different things that it can do. But today we're going to be focusing mostly on the distributed firewall and how it can help you protect and secure your data center from malicious lateral movement. So let's take a look at the current threat landscape. 44% of breaches reported lateral movement. It took 204 days to detect a breach, and the average cost of a data breach ended up being about $4.35 million. So what does this mean? This means that threats are real, they're hitting enterprises all over the world, and we need to do something about it. So how can we protect ourselves in this current threat landscape? So let's take a look at a traditional data center with only a perimeter firewall. Now, the perimeter firewall's job is usually to keep the hostiles at bay from coming inside the enterprise network. The enterprise network most likely does not have any east-west security. So what does this mean? Well, if an internal host is compromised, that lateral movement is going to allow the intruder free access to all the internal resources. As you can see, one workload is now compromised, and it's easily able to spread across the rest of the data center. And now the whole data center, including multiple apps, have been compromised. The data center can be designed around segmentation, but it's going to take a lot of work to do that. This is honestly going to take a lot of change controls. It's going to take a lot of manual effort from the networking and security teams. And you don't want network architecture to be designed or required to be designed around security requirements. The workloads are most likely going to be located in zones with some physical network constructs backing them, like subnets and VLANs. They're often going to be known, as in this example here, the green area is known as dev, the blue area is known as prod, and the purple area is known as PCI. Traffic can be exchanged between zones through the firewall, but this requires complex traffic steering or hairpinning. It requires capacity and scalability issues that are involved in this. Otherwise, this can be a very, very difficult endeavor to start going down in order to be able to secure your data center environment. The physical firewall ties the virtual infrastructure to the physical infrastructure. So the firewall in the physical infrastructure has no context, and it usually has poor granularity. It's usually a bottleneck within the data center, it's difficult to provision, and it introduces dependency to the physical network. The firewall inside the VM does have granularity, and it does have some context, but it does have user space performance because it's usually sharing the same compute and memory as all the rest of the applications that are living within the VM or the operating system. It can be compromised from within the OS. So if the operating system is compromised in any way, shape, or form, they're going to immediately shut down the agent-based firewalling that is working inside, and thus it is no longer going to be effective. And obviously, it's going to be a per OS implementation. The VMware Distributed Firewall has that granularity and has that context. It is kernel space performance based instead of user space performance based, and it is out of reach and independent of the guest OS. So with the VMware vDefend distributed firewall, we have the finest granularity possible because we are a firewall that is instantiated on each of the VM's VNICs. There's no wasted bandwidth and no hairpinning because we don't have to send the traffic to a perimeter firewall for traffic enforcement. Traffic is enforced, policy is enforced as close to the source as possible. In this case, the VM's VNIC. We have flexibility because the DFW is a stateful firewall that moves along with the VM. So the location of the VM is irrelevant and independent of its network connectivity. Meaning, if we have a VM that moves from one ESXi host to another, the policy and the enforcement follows it no matter where it goes. So let's simplify how this all looks with some basic colors. So in this case, we're going to have firewall rules that are expressed on groups based on some abstract tags, and we're just going to call them by their colors. So we're going to have a green group that has VMs that are tagged as green that can talk to purple, but we're going to have green VMs that are not going to be allowed to talk to blue VMs that are tagged as blue. We would simply go through and add these tags or apply them to the VMs as metadata, and they will join the green group. We'll go through and be able to do the same thing for the purple VMs. Well, we'll add a purple tag to them, and now they are part of the purple group. And then finally, we're going to have these VMs for the blue group tagged as blue, so they are part of the blue group. We can then create the corresponding firewall rules that are automatically enforced. So now in this case, green can talk to purple, but green cannot talk to blue. Now, if we were going to change those colors around to be realistic things that we have within our data center, green can be dev in this case, blue can be prod, and purple can be PCI. So now we've created 3 zones in their communication policies with just a few clicks. So let's talk about the VMware vDefend security portfolio as a whole. So in order to protect your critical apps, we have the firewall, the IDS IPS anti-malware, and the NDR. All of these components can be used either singularly or combined together to be able to help protect your environment. This is all under the unified management plane with security analytics, and all of this runs over your VCF private cloud. That means we can give you macro and zone segmentation, micro-segmentation, and ransomware defense all in one portfolio. So let's break down the portfolio just a little bit more. On the very bottom, where we have micro-segmentation or zone segmentation, we have our distributed firewall and our gateway firewall. On top of that, to perform ransomware prevention, malware prevention, and be able to defend yourself from any vulnerabilities, that's where our ATP comes into play. And then finally, on top of that, we have security intelligence for your app discovery, your security analytics, and your rule recommendations. All of this provides your comprehensive lateral security, all AI powered for your threat analytics. So let's talk about the legacy architecture versus our vDefend security architecture. So simply put, right here, we have a few hypervisors, some VMware ESXi hypervisors, and some VMs that are living on top of an infrastructure. If I wanted to have network-based firewalling, I would have had to have a separate component for that. And let's be honest, network-based firewalling can be manual and labor-intensive, and they're IP and subnet-based overall. If I want to add in another level of in-depth security, like IDS IPS, we would have to add in another device to be able to do this. And it's going to have no environmental context, it's going to have no east-west visibility, and most likely because it doesn't have that full environment context, it's going to have a high false positive rate. Let's add in another device, like let's say a network sandbox. The detection technology easily bypassed by evasive malware, and it fails to detect advanced threats. Remember, it's a separate device that is not interacting with the network-based firewalling or the IDPS that we have out there. And then finally, if we want to have it interact with our network traffic and analysis, it's difficult and costly to hairpin 100% of the traffic, and it has high false positive rates just like the IDPS. We're having to put in span ports, we're having to put in packet brokers to be able to send it to all of these different devices. And because they're all separate, we're having to do separate purchase orders, and these things become very expensive to get full comprehensive security. Along with the fact that these are all separate devices that are out there, we have to have some way of being able to then correlate the data into a singular pane of glass, if you will, or a singular monitoring station. That means being able to take a little bit from the network-based firewalling, a little bit from the IDPS, a little bit from the network sandbox, and a little bit from your network traffic analysis, and try to then be able to manually, either through scripting or some other way, be able to correlate that data together to know what is actually something that is actionable versus something that might be a false positive by one of these different elements. This becomes operationally complex, it becomes very difficult at scale to be able to manage, and there is a need to be able to then combine this technology in an easier way. And that's where vDefend comes in. Because now we take those components and we spread them off into the NSX firewall that's hypervisor-based advanced threat protection. We're able to then see, through no network changes, hypervisor observability, we can do segmentation and microsegmentation, and we can do NSX network detection and response. And that NDR capability is a tapless NTA where we get the east-west visibility, we get to use the sandboxing technology to do guest introspection, we do NSX distributed IDS and IPS along with our distributed firewall, and we do network event correlation. All of those things, because they're all built into the same product, are able to talk to each other, and we can then help you build campaigns which allow you to then be able to identify a threat in real time and figure out exactly what needs to be done to be able to mitigate that problem. So let's look at the difference between a traditional firewall and a vDefend firewall. So on the left-hand side there, we're talking about a traditional firewall. It's traditionally there to be able to protect the perimeter north-south and the zone-based traffic. So for example, if we have maybe a traditional firewall that has a web zone and an app zone and a database zone for web tier, app tier, and database, it'll only be able to defend if traffic reaches up into that firewall so that it can go between the interfaces. But let's say we have traffic that we want to be able to analyze on the same layer 2, that same subnet, like the web services. We cannot be able to, we're not able to take a traditional firewall and be able to look into the traffic and do any type of lateral security protection between things that are on the same subnet. So what will we do? We would have to re-architect the network. We would then have to separate those web servers onto 2 different subnets, create interfaces on that perimeter firewall, and then apply traffic policy to them. That means that now, yet again, our architecture is being driven by our security requirements, which becomes very difficult at scaling over time. Whereas with the VMware vDefend firewall, we have that virtual DMZ, we have that east-west traffic analysis, and it doesn't matter if they're on the same layer 2, because we're doing firewalling at the VNIC level, we're able to go in there and do protect the traffic right there as it goes in and out of the VM. A traditional firewall is a hardware-based architecture, which means that usually when you're going to go buy a traditional firewall, we try to figure out how many hundreds of thousands or millions of flows are going to go through it. We try to figure out what the licensing is going to be, and we hope that we only have to go ask for money one time. But when you have the vDefend firewall, it's a distributed software architecture. So what does that mean? Well, that means that as we add more hypervisors into the NSX vDefend fabric, that means your vDefend fabric, your protection, your ability to be able to do distributed firewalling and distributed IDPS grows as well. So now you're not locked down to a singular device and worried about hitting the upper limits of it. You have the whole infrastructure that is capable of protecting every single VM and the policy that is installed at the VNIC level. A traditional firewall, it's hard to scale out. You can do the addition of additional firewalls for active passive or active active, but as you want to scale that out, it becomes very, very difficult to add more appliances to it. Where we have elastic scale. As you grow, the amount of throughput that you can go in and out grows as well. All you have to do is just add in additional hypervisors that are prepped for NSX and the VIBs, and next thing you know, you have greater scale. A traditional firewall is all IP-based rules. That becomes complex to manage. As changes are made, you have to add new IP addresses into those groups, and as they leave the environment, you have to make sure to remove them. Because if you do not remove those IPs in those groups, guess what? If that IP address is reused for another workload that is part of another application, you now have all of a sudden let that application be able to reach resources in the enterprise network that probably was not meant to do or have. So with tag-based rules, when you're using dynamic matching criteria like these tags, if a VM is born into the environment and is tagged appropriately, it is now automatically added to the group. And since those groups are used to be able to create policy, it is now added directly into the policy. And when that VM is removed, all of a sudden now it will be dynamically removed from the group. Its IP address will be unlearned or taken out, and then thus it won't have the policy applied to it, and you're doing optimization of your groups, the IPs that are utilized in the groups, and optimization on your rule set. A traditional firewall has higher TCO because those things are very, very expensive. They're purpose-made devices, as opposed to the vDefend firewall, where you're using your normal compute, your hypervisor, to be able to provide the security functionality and the networking functionality all in one. With an in-guest agent, it has to rely upon a rudimentary host OS firewall. So we're talking IP tables, we're talking Windows Defender and Windows Firewall. VMware vDefend Firewall is a full-stack distributed firewall, and it lives below the operating system. So what does that mean? Well, it means that with an in-guest agent, it's susceptible to the workload compromises as well. So if a workload is compromised by something that is malicious, its first act that it's going to do is shut off that host-based OS, that IP tables, that Windows Firewall, that Windows Defender. And now it can be affected even more. It can now start doing scans inside the rest of the enterprise network, and it could be used as a host to be able to then perform malicious lateral movement. With VMware vDefend, if the operating system is compromised, it can't go in and shut off vDefend. It can't stop the VNIC from processing that traffic and protecting it because it lives below the OS. An in-guest agent competes with the application resources. It needs resources like CPU and memory, just like the rest of the applications do. Whereas with vDefend Firewall, we're not using the OS at all to be able to do protection of the traffic that's leaving in and out of the VNIC. In-guest agents only capable of layer 3 to layer 4 functionality. We at vDefend are able to do layer 2 to layer 7 functionality. So everything from the layer 2 side all the way up to complex layer 7 and application ID, we have the ability to do that. And remember, it can't be shut off. Agent lifecycle is very difficult as things grow and you have to deploy more of these agents and update them. It takes a complex infrastructure and it takes a very in-tuned IT department to be able to maintain this. Whereas with vDefend Firewall, it's a seamless deployment. You deploy it out, it's able to do all the functionality. And remember, you can do things like apply to field to be able to optimize it, which we're going to talk about very soon. We don't just do lateral security for VMs. We also have it for containers and bare metal as well. You can achieve that zero trust, you can achieve that lateral security, you can achieve that protection from ransomware, all with our portfolio. We have the VMs that are protected by the distributed firewall and the gateway firewall. We have the containers that are protected with Antria. And then we have bare metal. We have our own agents as well. We have a Windows and Linux-based agent, and also you can protect those bare metal workloads with Gateway Firewall. So Gateway Firewall has the ability to be able to help you out not only with your regular VMs, but also with your legacy VLANs. You can have them connect up to a tier 1, and you can do protection even if you don't want to have an agent in them. So with this wide portfolio, we're able to protect your workloads no matter how you bring them into the data center. Now, we're going to jump deeper into VMware vDefend Distributed Firewall. We're going to look at use cases, and we're going to look at how the technology can help you in your macro and micro segmentation journey in protecting your data center. So what are some of the features of the Distributed Firewall? Well, the Distributed Firewall provides visibility and control for virtualized workloads and networks. The Distributed Firewall has the following main features. It has centralized configuration through the NSX UI or API. It has layer 2 stateless firewall rules, layer 3 stateless and stateful firewall rules, context-aware layer 7 firewall rules, identity firewall for Windows workloads, FQDN filtering, blocking malicious IPs, and time-based policies. One thing I also want to note is the fact that you can use the distributed firewall both with your overlay network segments and also purely just with your virtual distributed switch and the virtual port groups. So let's look at some of the vDefend firewall key concepts. We have a security policy, which is a collection of firewall rules and service configurations. We have a firewall rule, which is a set of instructions that determine whether a packet should be allowed or blocked. We have groups, which help make up firewall rules, and it is a construct with multiple objects statically or dynamically pulled together. A service defines a port and protocol combination and is used to specify the type of traffic to be blocked or allowed in firewall rules. We have a context profile, which inspects the layer 7 content of the packet to allow or deny them. So let's say, for example, we had an HTTP stream that we wanted to have that was going between two VMs. If we simply were to put the layer 4 information, allow TCP/80, we have no idea what the context or the content of that packet involves and if it actually is HTTP. But if we do layer 7 inspection, what we'll do is actually crack open that packet and make sure that the payload is actually HTTP. If it does match it, then we're going to either allow it or deny it based on how we want the firewall rule to execute upon that match. And then finally, we have the applied to field, which allows rule optimization by allowing you to choose which VMs the policy will be enforced on. We're going to take a look at this a little bit more in depth in some slides in the future. So let's take a look at some of these key concepts. For example, the groups. The groups are used for your source or your destination or your applied to field. They can be made up of a few different things. So we can have static members, we can have IP and MAC, we can have criteria based, and we can have IDFW or identity firewall. Our static members could be virtual machines, VNI, groups, segment ports, and segments. We can have for our IP and MAC IP addresses, which could be just singular IPs, they could be ranges of IPs, and they could be CIDR. And then we also have MAC addresses for our layer 2 firewall rules that we can have. We have criteria-based, which are logical ports, logical switches, virtual machines, IP set, OS name, and computer name. And in this case, we most likely want to have our criteria based on tags so that we can have virtual machines that are tagged dynamically added to these groups. And finally, we have in our identity firewall 80 groups. And this is our ability to be able to connect in to an Active Directory controller, pull down the groups from an OU, and then figure out what users are actually part of those 80 groups, and then apply those in identity firewall policies. This is used for RDSH and VDI, and we have a full use case on identity firewall that we can dive deeper into if you are more interested. So let's take a deeper look at the tags. If we have some VMs that are customer facing and internal, we might have a bunch of tags created for web tier, app tier, database tier, a traditional 3-tier app. We might have our different environments like our production and our development, and we might even have a zone for compliancy. If our first VMs that are customer internal facing are for the web tier, we're going to go ahead and tag these VMs with a web tier tag. Now, in this other area in the customer internal facing, these other VMs are application tier. So we're going to go ahead and tag them as application tier. And then finally, we have some VMs that are part of the database tier. Now we can add additional tags to add more metadata or more information so that we can create some unique dynamic matching criteria for some very unique rule sets that we can create that might not be possible in other perimeter-based firewalls. So in this case, in App 1, we have a lot of VMs that are part of the production area, so we're going to tag them all as that green tag production, and same with the internal. And then finally, the customer-facing app happens to be part of the PCI zone, so we're going to add one more additional tag for PCI. So now, in the customer-facing area for App 1, I can easily figure out which VMs are part of the web tier, are part of production, and which ones are part of PCI, or which ones are part of the app in the database tier, just purely by looking at the tags that are attached to them. Services and context profiles are one of the other key concepts that we were talking about when it comes to creating firewall rules in the DFW. We have our layer 2 and layer 3 services, our layer 4 services, and our ALG services. The layer 2 and layer 3 services are for Ethernet or IP protocol level enforcement, but remember the layer 2 is only available on the distributed firewall. The layer 4 services are the protocols, i.e. types, and the ports that are assigned to that service. So for example, TCP/80, TCP/443, many other ports that are out there, DNS, and so many more. We have ALG services, which are dynamically open ports. So for example, in FTP negotiation, it will have to figure out what type of port it's going to use for the data transfer. We'll crack into that, be able to understand what port is negotiated, and then open up the firewall to allow that transaction to happen. And we have 7 built-in ALGs that are listed, and there's full listings of this in the documentation. And then of course, our layer 7 profiles are that deep packet inspection engine that I was talking about, where we can crack into, let's say, a MySQL packet and make sure that the payload is actually MySQL and not something else that could be malicious that may compromise the workload. You can see that the layer 4 services go into the service area of the firewall rule, in this case, TCP/443 HTTPS. And then we have our layer 7 context profiles that go into the profiles area. And in this case, we're looking at TLS 1.2 in the very first rule. And notice how we're using the groups that we talked about earlier, in this case, HRM-VIP and HRM web tier, to be able to identify the workloads that we want this rule to pertain to, and the apply to field we'll talk about in just a few slides, to be able to then only install these rules on those VNICs that are part of the HRM app group. So what are the different combinations of firewall rules that we can create with just layer 4 and also layer 7? Well, in this case, we can have port-based enforcement, which is purely just layer 4 firewall rules. So in this case, we have a source of any going to MRS web tier on TCP 443 or HTTPS, and we're not doing any layer 7 here, so the profile is any. We can do port and app ID based enforcement, which means that we're going to not only identify the port and protocol in the services area, but we're also going to identify what layer 7 context profile we're going to be wanting to check the packet for. So in the second rule here, we have MRS web tier going to MRS app tier, that destination, on TCP 80 or HTTP, and we're looking to make sure that this is actually HTTP traffic that is within the payload. And then finally, we have port independent enforcement, where in this case, we have in the second rule, MRS web tier going to MRS app tier. We're checking on any port, and we're going to send this traffic to the layer 7 deep packet inspection engine to make sure that that packet actually is HTTP. And if it is in this case, then we would allow it. Otherwise, we would deny it. So now let's talk about that final unique thing that we have with the distributed firewall that makes us unlike any other firewall out on the market. And that's the apply to field. And the apply to field dictates the scope of the rule enforcement and optimizes resource utilization. So we have a very simple example here. The very first rule is an any to any rule on DNS and NTP services, and we're going to allow, and we're going to set the apply to all VMs. Now you may see this in the actual vDefend interface as apply to DFW, but for all intents and purposes, we're going to keep it simple and say that the apply to field is all. Next, we have the green VMs that need to reach a destination of the database 1 servers, or DB1. On the service of MySQL, we're going to allow it, and we're going to only apply to the green VMs. And finally, we have the blue VMs going to the destination of DB2 on the MySQL service, and we're going to allow it, and we're only going to apply this rule to the blue VMs. So why is this important for rule optimization? Well, when it comes to the second rule, with the green VMs reaching DB1 on MySQL, this rule will never pertain to the blue VMs. So why would we need this rule installed on the blue VM's virtual distributed firewall on the VNIC? We don't. The answer is there's no reason for it because it'll never pertain to it, so it should never really be assessed. And the same is for the blue VMs, where there's no reason that they should have the green VM rule, so why don't we just take that out? So this is how we can have efficient rule enforcement on the VNICs of every VM. So in this example, with the apply to field, we're now going to have the green VMs. They will have, if you look in their distributed firewall, in their VNIC, you're going to see only 2 rules installed. The any DNS NTP allow, and then the green rule of VM 1 and 3, because they are tagged as green VMs, they're going to be part of that green VMs group, so they will be the source going to DB1 on the service of MySQL, and we will allow that. And for the blue VMs, because VM2 and VM4 are part of the blue VMs group, they will be the source going to destination of DB2 and on the service of MySQL, and they will be allowed. So instead of having 3 rules on each of the VNICs of the distributed firewall of each of those workloads, we only have 2 rules. So now we have optimized the rule sets for the rules that only pertain to those VMs. One last thing I would like to review before we go to the full viewpoint of what a section and a rule looks like in the distributed firewall is our security rule model. So we have some predefined categories: Ethernet, emergency, infrastructure, environment, application, and finally the default policy. The Ethernet category is used for our layer 2 policy. Our emergency is for quarantine or any other type of rules that are needed for allow or deny that are usually on a put in like a break glass methodology where I need to have this immediately, and we don't have a way of being able to put it into the other categories because let's say it was an emergency where something happened in the environment or there was an outage and you wanted to put a rule in at the very top of your firewall. We recommend putting it in the emergency category so it's assessed first. The infrastructure category is your global policy for your common services, like Active Directory, DNS, NTP, DHCP, backup, management servers, all those different types. These rules are usually, when it comes to the applied to field, applied to the DFW or all. The environment category is policy between zones. So this could be prod versus dev, PCI versus non-PCI, or other inter-BU rules. And finally, we have our application category, which is our most in-depth and most granular style of rules. And it's usually policy between the apps, between different business units or different applications within the business units. You would put these rules inside of here. This will pertain to macro policy and also lead you into the journey of finally having your microservices policy where everything is locked down to a zero trust model. Your default policy is the allow list or zero trust policy. So, the IP any allow or IP any deny. Finally, each category can have multiple policies and rules inside of them, and they're enforced from a top-down, left-to-right manner. So now that we have gone through all of the key concepts, let's look at this from the UI. So at the very top here, we have a section called VDI, and we have a rule within the VDI policy for blocking inbound to VDI. In this case, we have a unique ID, and that is the differentiator or the unique identifier between all the different rules. You can't have multiple rules with the same ID. It would be denied. It would not be allowed to happen. So each rule must have a unique identifier. You have the sources, which in this case, it could be any, or it could be any of the groups that we have created, which we talked about, which could be dynamic matching criteria or static members. So in this case, we have the source being any and the destination being a group called VDI desktops. We have services, which could be our predefined or custom services or service groups. It could be the ALGs that we have for being able to negotiate ports for FTP or any other of those services that are listed. And then finally, we have our context profiles, which is used for layer 7. And finally, the applied to field, which we talked about in the last slide, which tells it where this rule should be installed or what VNIC should it be installed for what VMs. We have our actions of allow, deny, and reject. And then finally, we can set the settings by default to be in and out, or in, meaning into the VM, or traffic out, leading out of the VM. So now that we've had an overall view of how the VMware vDefend distributed firewall works, let's start to take a look at some of the use cases that we see customers utilizing this technology. So we have secure infrastructure, which we're going to talk about in the next slide and explain what that means. But essentially what we want to do is use the vDefend distributed firewall to be able to lock down our common services and protect them from potential malicious traffic reaching them, which then could lead to more malicious lateral movement. We have our secure virtual zones. This could be our prod, our QA, our UAT, or our dev zones. It could be our PCI. It could be many different types that we decide to create, and we can create broad-based rules to be able to protect them from each other. So for example, if we don't want the dev virtual zone to be able to reach the prod virtual zone, we can create that with a simple group that says dev servers are not allowed to reach prod servers. Finally, in secure apps, I like to break this up into two different areas. We can protect the applications from each other, or in our microsegmentation journey, we can journey inside of the app, and then we can protect the assets from each other. Even if they are on the same layer 2 or the same IP address subnet, we're allowed to protect those. And this is an area where a perimeter firewall or a zonal-based firewall would not be able to help you. And finally, we can use the vDefend distributed firewall to be able to protect our PCI zones, our HIPAA zones, SOC, ISO, or any other type that we have out there. So let's look at some examples of our secure infrastructure. On the left-hand side, we have application XYZ, and it's made up of many different components. In this case, it's going to be a traditional 3-tier application, a database, an app, and a web server. Below that in the orange area, we have application ABC, also made up of a database, application, and web. Infrastructure services are on our right-hand side. Now, this could be Active Directory, it could be DNS, it could be a file server, it could be many different things, a patching server, you name it, it could probably be a part of it. So we want to, in this area, allow potentially applications from the application XYZ area to be able to reach infrastructure components, but ABC may not be able to reach some. In this very simplified model, we made it so that XYZ can reach the Active Directory server, the DNS server, and the file server, but ABC is able to reach the Active Directory server, the DNS server, but not the file server. This could be as in-depth as you want. You can actually crack into the application and only allow the web to be able to reach the file server on XYZ, but deny the app in the database. It really comes down to how you make the groups and how you tag the VMs, and this can lead into more granular policy or more broad-based policy. When we talk about securing our virtual zones, in this case, in our example, we're going to have prod, QA, UAT, and dev. Prod is going to make up many different applications, in this case, app 1, 2, and 3. Dev will be app 4, 5, and 6, UAT 7, 8, and 9, and QA 10, 11, and 12. I don't want prod to be able to talk to dev, so I can create in one simple rule with all of the VMs or all the workloads in the prod area that comprise app 1, app 2, and app 3 to be tagged as prod. App 4, app 5, and 6 are all tagged as dev. I then create a rule that says prod cannot talk to dev, and it will apply to all of those workloads that are tagged as such. We can allow prod to be able to talk to UAT in a similar fashion by taking app 7, 8, and 9 and all of the VMs that make up it and tag them as UAT. And then QA, app 10, 11, and 12, take all the tiers and tag them appropriately with the QA tag. This now allows me to make some macro segmentation rules that allow everything to happen with just a few simple rules. Prod not allowed to talk to dev, prod can talk to UAT, dev can talk to QA, but prod can't talk to QA, dev can't talk to UAT, and UAT can't talk to QA. So with very simple rules and using dynamic tagging, we're able to then identify workloads and then shut down communication with just a few simple clicks or API calls. With secure apps, I like to break it up, like I said, into two different areas. In this first area, we're going to talk about application protection. So again, app 1 is made up of a web tier, an app tier, and a database tier. App 2, much the same, web app and database. App 3, web app and database. App 4, web app and database. In this case, I want to be able to have app 1 be able to talk to app 2, so I'll make a global policy that allows all of app 1 and those VMs tagged as app 1 to be able to speak to app 2. App 3 and those VMs tagged as app 3 will not be allowed to talk to app 4 in any way, shape, or form. But then I can create policy to allow app 1 to talk to app 3 and app 2 to talk to app 4. And then finally, in our microsegmentation journey, we can crack open into app 1 and allow policy between the tiers. So in this case, I say web can talk to app, but app can't talk to database. Now, of course, in the real world, we would have application tiers talking to the database tiers, but just for the example, I wanted to show that we can actually go in and limit traffic between the tiers. And even more in depth, if we wanted to crack open into multiple web servers, we can allow or disallow connectivity between them as well. Now, just because we're doing microsegmentation in app 1 doesn't mean that we have to be overall granular for the rest of the applications. We can work our way into microsegmentation into app 2, 3, and 4 in the future. So you can see we're doing still macro segmentation between app 3 and app 4, and we're allowing app 2 to be able to talk to app 4. But we can still go a little bit more further in app 2 and app 4 by saying the database servers are not allowed to talk to each other. We allow you in vDefend Distributed Firewall to have the flexibility to create whatever type of rules you want, whether it be macro segmentation all the way down to the most granular microsegmentation that you can think of. And then finally, we can have our in-scope PCI zone that is made up of different VMs like web, app, and database, and we can lock down what applications are allowed to talk to each of those tiers. In this case, XYZ, globally can reach the web and it can reach the database, but it's not allowed to reach the app. And application ABC does not have the ability to reach the web and the database server, but it can reach the app. Again, we can go very fine, ingrained policy if we were to tag these each separately and then create groups and dynamic matching criteria to only allow, let's say, the XYZ, the database server in XYZ, to be able to reach only the database server in the PCI zone. You have the power and flexibility. You can create the tags, you can create the groups and the dynamic matching criteria however you want, and vDefend will be able to protect your workloads. In this presentation, we principally talked about the distributed firewall. We talked about how it provided zero trust security by installing microsegmentation policy in each of the VM's VNICs within the hypervisor kernel. This enables every VM to have its own firewall. We talked about the capabilities of it, i.e. just being able to do layer 4 firewalling all the way up to layer 7 firewalling. We talked about the use cases of microsegmentation and macrosegmentation and compliancy and segmenting of zones. But on top of that, we have things like gateway firewall. We have a whole portfolio on advanced threat prevention, and also finally security intelligence, doing that app discovery, security analytics, and rule recommendation. All of these things put together provide the comprehensive lateral security that allows you to protect your data center from malicious bad actors that might want to infiltrate your workloads, spread across it, and then start to exfiltrate data. I think the main point I want to get across is the fact that we have a wide variety of ways that we can protect your data center. So, for example, we can use a bare metal agent to be able to protect your bare metal workloads. We have the ability to do distributed firewall on overlay networks. We have the ability to do distributed firewall on your virtual distributed switch. If you have legacy VLANs or underlay VLANs in your enterprise network, we can allow the gateway firewall to be able to protect them as well. We can do advanced threat protection with IDPS, with malware detection and prevention. We can do NTA and NDR. And then finally, we have security intelligence that can do app discovery, security analytics, and rule recommendations.